Welcome to our exploration of electrical theory, the essential foundation for fire alarm and electrical work. This knowledge is crucial for ensuring safety, reliability, and efficiency in real-world applications. Electrical theory is the backbone of all electrical and fire alarm work. It helps ensure safety, reliability, and efficiency, making installations safer and troubleshooting faster. Let's delve into the basic electrical quantities: voltage, current, resistance, and power. These are the key formulas that drive electrical work, helping us understand the flow and opposition in circuits. Ohm's law defines the relationship between voltage, current, and resistance. It's critical for calculating device current draw and troubleshooting circuits, ensuring everything runs smoothly. Power, measured in watt-hours, is the work performed by electricity. Understanding energy consumption is vital, especially in fire alarms where battery backup is crucial for reliability. Series circuits offer a single path for current flow, with voltage dividing across components. This concept is useful for understanding device supervision and is exemplified by old holiday light strings. Parallel circuits provide multiple paths for current flow, ensuring redundancy and reliability. Voltage remains the same across branches, making them ideal for fire alarm NACs and smoke detectors. Understanding the difference between AC and DC is essential. DC provides a constant flow, while AC changes direction periodically. Both are used in fire alarm systems for optimal performance. Impedance opposes AC circuits, while capacitance stores energy in electric fields. These concepts are important in filters, surge protection, and power supplies, smoothing out ripple voltage. Grounding and bonding are crucial for safety, preventing electrical shock by ensuring metallic parts are at the same potential. This is a requirement by NEC and NFPA standards. Electrical theory is applied daily in fire alarm systems, from voltage drop calculations to battery sizing and wire gauge selection, ensuring reliable operation and effective installations. Using a multimeter to measure voltage, current, and resistance is key in diagnosing problems. Ohm's law helps trace faults, confirming circuit health and ensuring everything functions correctly. In summary, electrical theory is essential for safe and effective work. Understanding core concepts like voltage, current, resistance, and power, along with circuit types, improves troubleshooting and reliability. We welcome your questions and comments. For further study, explore resources like NFPA guides and NICET certifications. Thank you for joining us in understanding the vital role of electrical theory.